Hello everyone, it's KP the Math G here. I'm so delighted to be here. It is getting closer and closer to Christmas. It kind of reminds me of a limit, doesn't it? Getting closer and closer to some number or zero or whatever. Well, anyway, bad joke. We are integrating by substitution, and I do have this as part 4. In previous parts, I had started off very light and easy, and then this has gotten progressively more difficult. This problem was in part 3, and I'm going to include it in part 4 simply because my camera, for whatever reason, after so many minutes would just cut off, and maybe I just don't have enough memory. I don't know, maybe somebody can help me with that. I may need to get a little more memory so I can not worry about my time running out. So anyway, let's go ahead and let's get started with this. I wrote this problem out from the last video, and I want to address this one now. Okay. Notice that we are integrating by substitution. Anytime you see pretty much e or something raised to some power like this, that is what I'm going to let u be. And we've gone through some other videos to show to try to help you understand what I need to let u be and why. Alright, this is tangent of 3x. And the reason I'm picking that is very simple. Excuse me. The reason I'm picking that is that when I take the derivative of both sides, I'm going to get this back. Actually, I'm going to get a little more than this back. So let me move this line out of the way because I need room. Du is equal to, now when the antiderivative of, or the derivative rather, of tangent is secant squared. Secant squared 3x. Now remember, you do have a chain rule. Okay? Take the derivative of 3x, which is just 3, and then tack on dx. So times dx right there. If you look very carefully, we have that and then a little more. Secant squared 3x dx. Secant squared 3x, 3 dx. I have too much right here. Okay? Please understand that. How do I get rid of 3? Well, two ways. I can either divide by 3 or I can multiply by 1/3, and I'm going to do just that. So 1/3 on this side, if I multiply this side by 1/3 and multiply this side by 1/3, I have 1/3 du is equal to secant squared 3x dx. Now the 1/3 multiplying that gets rid of that 3 here. Okay, and that is what I want. d1/3 or du then, or 1/3 du is equal to all this. That's what I have here, isn't it? Alright, u is here, du is all of this, isn't it? Alright, so look what I have. I have e to the u du, don't I? I left something out. In one of my previous 2 videos ago, I left something out, and it's the same exact number, 1/3. Okay, so 1/3 goes out in front. Do not do like I did and forget that. Okay? Okay. 1/3, all right, u, yeah, e to the u, and then du. Okay, there it is. I know what the antiderivative of e to the u is. It's just e to the u, isn't it? So here we go. 1/3 e to the u. Oh, I don't know why I'm doing that. U. Okay. Plus c. Okay. U is tangent 3x, so now we have 1/3 e to the tangent 3x, and you can plug that in right away if you already know that that's u, and we should probably just come straight down to this. If you already know what this number is, you already know what u is, plug them in. Sounds good to me. And it works. Okay. Alright. There is what you need to do there. And that was from the last lesson. Okay, now we have a part 4 for a specific reason. So far we just have been finding the general C, as we have, not a specific or particular solution. So we're going to go back to doing that particular solution. Alright, let me get another, I need to clean this eraser. Pardon me while I'm trying to clean this, and that's just the downside to this. I always have to clean it. I do have the back of the board, yeah, but I'm going to use it for another problem. Okay, another question. This does take a little time, so I'm sorry. Please bear with me. Okay. I just felt like this was a good time to address this problem here, because my video stopped right in the middle of this problem, and I wanted to go ahead and finish it. And I like to finish things like this. Yeah, okay. Alright. I probably need that spray for Christmas in my stocking or something. Okay, now let's get another problem. Okay, so this time, oh well, no, we're not looking for a particular solution. I'm going to call this these are called special cases. And we may just have time to do one, I don't know, but we need to really think about this one. I'm going to integrate this, t, and we're going to have the cube root of t plus 10 dt. It is done by substitution, okay? But the deal is, usually something inside the radical, this would be a square right here. That would be so much easier if this were a square here, believe me. Because then if you take the derivative of that, then that does leave you with something in the form of t dt. We don't have that. So first of all, let's rewrite the problem. Alright, this can be a little bit difficult. Okay, to the 1/3. Remember that's the same as writing that to the 1/3 dt. Okay. Alright, I love this problem. I may have to do 2 separate lessons, maybe another part to get the next problem in there, but we may let's just see what we can do with this one. Now, always we're going to let u be this. Always. Here's the problem. If we let u be this, and we have to, let u be equal to t plus 10. Here's the problem. I need to have a t dt. If I just go ahead and do this haphazardly, this is just du is dt. Usually say dx, but dt. I need a t dt. So here's how we do that. We can't just do it this way and try to integrate. That's not going to work. I need a t. Alright, so here's how we do this. when you see the same exponent like this here, and a lot of times it is a 1, okay, sometimes it's not, but if you see the same exponent here, you got to do a little something different here. That's why this is a special case. So here's what we're going to do. Now remember, we didn't let all of this be to the 1/3, just this inside be equal to u. Here's what we got. U, let's get t by itself, because I want t by itself. If I do that, I'm simply going to subtract 10 on both sides. Okay, and when I do that, alright, u minus 10 on both sides. Alright, so u minus 10 equals t. See how that's gone right there? Now, okay, I need to kind of keep everything in perspective here. I don't want to cross that 10 out. I want to leave that there. So u is equal to t plus 10. T is equal to u minus 10. So here's what we have here when we set this up. Okay, I'm going to go ahead and substitute right here. What is t? It is u minus 10. That's what t is. That's the reason when we have an exponent that's the same like this, you want to go ahead and let u be this. Not this, but this. Okay? And then go ahead and solve for t, because you got a t sitting out here. That's the reason we have to solve for t. Alright? So u minus 10 in place of t is right here. Now, what is going to be raised to the 1/3? Well, u, okay, is t plus 10. So in place of t plus 10, I'm going to put u right there. dt. And that should have been, just in place of that. Okay. All right. And so that's what we have to do on that particular problem there. Okay. See that? And of course, if you want to do du is equal to dt, you could do that. Okay. But we have everything that we need here. We just wanted to substitute in place of these two here. Well, du, yeah. So du, left side, is equal to dt. We do need that. Okay, because we do need to replace that. We're substituting everywhere. Okay. Okay, there it is. That's just to get there. We're doing really, really good. Now, that's one of the, we may just talk about this one problem here. Okay, and then on the next video do another one just like it, but let's concentrate on this one, okay, because if I try to do two, I'm probably going to run out of time. Okay, now when you see this situation, now again, had this been a square here, we could say let t squared plus 10 be equal to, or let u be equal to, alright, let u be equal to this, then du is equal to 2t dt, and then we could have dt, if we multiply by 1/2, we would have 1/2 du is t dt. We don't have a square here. Unfortunately, we do not. So when you have this situation, you got to be able to recognize that situation. Okay? You have to be able to recognize that particular situation. This is a special case here. Okay? Alright, so u is t plus 10. That's what u is right here. U minus 10 is t. Alright, u minus 10 is t. Got to get t by itself. We've got to have something for t. And then du is dt, so in place of dt, there's du. Now, let me erase, well, I need to keep that up there. Okay. Alright, so let's see if we can start to integrate. I may have to flip the board over for this. We can, this is u to the 1/3. I don't need that parenthesis there. Alright, now, u to the 1/3, let's distribute this. Alright, now if I have a denominator of 3, this is 1, isn't it? You see that? Okay, I want to change the 1. I want my denominator to be 3. So what does the numerator have to be to still be a 1? Yes, that's right, 3. 3 over 3 is 1. Alright, so here we go. I like this. Now I can distribute this. It equals. Alright, remember when you multiply, you simply add the exponents. 3/3 plus 1/3 is 4/3. So u to the 4/3 minus 10 times u to the 1/3. Alright, u to the 1/3 du. Man, if you get to that, you've got this. Alright, so I'm going to write this down on a sheet of paper and flip this over. We'll flip this over to see what we've got to do when we come back to it. Okay? Alright, so let me write this down. I keep plenty of paper, I tell you. I keep a lot of paper. Gotta have it. If you're a mathematician, you gotta have paper. Alright, so u to the 4/3 minus 10 u to the 1/3 du. Okay, I'm going to flip the board. U to the 4/3 and u to the 1/3 du. Okay, I always double check. Okay, let's flip my grandson and me upside down. Oh, okay, I've got boxes here. It's Christmas time and I got boxes on my bed. Okay, here we go. Alright. How convenient, I write KP the Math G on both sides of the board. Alright. I want people to know who's talking here. I'm KP the Math G here. My kids named me that when I taught school. I didn't name any of this. Okay. U. We were at u to the 4/3 minus 10 u to the 1/3 du. If you want to divide this up, you certainly may. Some people do that. U to the 4/3 du minus 10 u to the 1/3 du. You can do that. There's a rule that says you can. Okay, without going into the rule itself. This is the 4/3. Okay, there we go. Easy to integrate because this is u. Now remember, we're adding 3/3 to 4/3. 3/3 is 7/3. 7/3. 4/3 plus 3/3 is 7/3. Now remember, the way I do it, instead of putting 7/3 down here, I just flip it over and put 3/7 right here. Okay. Okay, so that's that one. Minus 10. Add 1 to this one, so that's actually 3/3 to that one. 3/3 plus 1/3 is 4/3, so that's going to be 10 u. Let's keep a little space here because I want to put something there. 10 u to the 4/3. Remember, that is going to be flipped over to 3/4. Then don't forget you have a plus c. We can clean this up just a little bit. We're almost home with this one. Okay. All right. So 3/7. 3/7 u to the 7/3. All right. Now let's see. This is over 1. Okay. 2 goes into both 4 and 10. 2 goes 2 times, 2 goes into 10 5 times. 5 times 3 is 15, 1 times 2 is 2. So 15 over 2. 15 over 2, u to the 4/3 plus c. Everybody see, if you multiply straight across, you get 30 over 4. 30 over 4 is 15 over 2. Okay. But now we let u be something from the start. I want to go back what I let u be. We said let u be equal to, alright, so let's find out what that is. Okay. U is t plus 10. Okay. U is t plus 10. Alright. T plus 10. So in place of u, I'm going to put t plus 10. So now, okay, up here, oh, I don't know, we'll see if we have room up here. Okay, so 3/7. 3/7. Now, t plus 10, t plus 10 to the 7/3. 7/3 plus 15 over 2. 15 over 2. T plus 10 plus 10 to the 4/3. We just got to put our plus c down here. Plus c. Okay. And that's it. Okay. Since that's quite a bit to absorb at one time, I do agree that is. I'm just going to let you absorb that just for a little bit, and then I'll come up with another video with one other problem just like this. Because if I try to do one or two things is going to happen. My camera's going to probably shut off for whatever reason. Maybe and I try to erase what's on there so I can have enough room for my memory. So my memory may be short on that. And then I'm just kind of getting accustomed to where I want to just do 2 problems or even 1 problem, because this is a lot to absorb here. Okay. Once again, let's look, because I don't want to leave you hanging and we still not understand. When you are faced with this, u is going to be this right here. Okay. Alright, u is always going to be that. Okay, whatever's inside raised to an exponent. Okay. And then we have to solve for t, because we have t dt here. So we have to solve for t. So that, in that case, is u minus 10. du, alright, and then we just simply multiplied this out. And if you can get to this, voila, you know what to do from there. And then that's just the idea. It's just getting to this right here. And then when you get to the end of the problem, you know that u is t plus 10. So all you got to do is remember to put that back in here when you finish your problem. Okay, you know how to integrate. Add 1, flip this over. Same thing here. 7/3. 1/3 plus 3/4 is 4/3, 3/4, and then simplify this, and then there it is. Just remember to substitute this back in there, and you got it. And that's it. And I think that's enough to digest for now. So this is KP the Math G. I want to say this is my 46th video. I think I just did my 45th one yesterday. My 46th video. My wife is gone to get some more Christmas presents. I'm pretty sure that she's getting me something else that I'm not supposed to know of. I think I'm going to get a pair of cowboy boots, but I'm not sure about that. And if she doesn't, that's okay. She's given me enough, and if I didn't get anything and I had her, that would be more than enough for me. Okay. She is my precious jewel. I love her very much. So anyway, putting everything aside, I hope that you have a wonderful day. KP the Math G signing off. Have a wonderful day.